Last class, we finished the first 5 questions, right? So this is the question number 6. It's about division of 2 complex numbers. If the denominator, if the complex number in the denominator has both real part and the imaginary part not equal to 0, then the way to process the division is to find the conjugate of the denominator. Let me hide the control bar. Denominator is 5 minus 4i. Its conjugate is 5 plus 4i. We have a formula that applies in this problem. If we have 2 complex numbers, they are conjugate of each other, a plus bi times a minus bi. Then the product of the 2 complex numbers is a real, non-imaginary real number without the I. The result is a squared plus b squared. It's good if you know the formula, just to make your job a lot easier. A plus bi times a minus bi, the product of the 2 complex numbers, they are conjugate of each other, is equal to the sum of the square of the real part and the square of the imaginary part, a squared plus b squared. So the denominator is 5 minus 4i. Its conjugate is 5 plus 4i. So if we multiply the 2 complex numbers together, 5 minus 4i times 5 plus 4i, knowing the real part is 5, the imaginary part is plus minus 4, then the result by the formula is equal to 5 squared plus 4 squared. We don't have to worry about negative 4 to the power 2, the same, right? Square of negative 4, square of positive 4, both are equal to 16. So 5 squared plus 4 squared. 5 squared 25, 4 squared 16, added together is 41. 11, 3, 4, 41. Okay, so when we divide 2 complex numbers with denominator complex number, real part is non-zero, the imaginary part is also non-zero. The way we process the quotient is to multiply both top and the bottom by the conjugate of the denominator, which is 5 plus 4i in this case. Equals denominator 5 minus 4i, 5 plus 4i. We got a result already, right? The 2 complex numbers are conjugate. Their product by the formula equals 41. Numerator 3 plus 7i times 5 plus 4i. Those 2 complex numbers in the product are not conjugate. Well, we really have to either use the box method or FOIL method to figure it out. I'm going to use box method. 3 plus 7i. The other complex number, 5 plus 4i. Row 1, column 1, 3 times 5, 15. Row 1, column 2, 3 times 4i, 3 times 4, 12, 12i. Row 2, column 1, 7i times 5, 5 times 7, 35i. Row 2, column 2, 7 times 4. Yeah, we are multiplying 7i and 4i. 7 times 4 is 28. I times I is I squared. I squared is negative 1. So row 2, column 2 is negative 28. You don't have to rush, by the way. You can slow down on your scratch paper. 7i times 4i, right? 7 times 4 is 28. So we have 28 times I times I. That is I squared. I squared is negative 1. 28 times negative 1 is negative 28. So row 2, column 2, negative 28. In the box, those 2 can be combined. They are just constants, real number constants. And those 2 can be combined. They are imaginary number. Imaginary number is the complex number with real part equals 0, but you don't have to worry about that. Just know they can be combined. After we combine them, 15 minus 28, you win $15 the first game, you lose negative 28, you lose $28 second game, so you end up with losing, right? You lose $13. The money you won from the first game cannot counter the money you lose the second game. So you end up with losing, negative profit, negative 13. And the two yellows combined together, 12, 35, 47, 47i, 47i. Let's see the requirement. Enter the answer as reduce the fraction when necessary. Reduce the fraction. Simplify the following expression. Enter the answer as reduce the fraction when necessary. Reduce the fraction. What does that even mean? Enter the answer as reduce the fraction when necessary. To me, this is good enough. But we can do one more step. Numerator has two terms. Denominator has one term. So we can use top one, the first term on the top, over the denominator. And plus second term in the top over the denominator. Split the fraction into the sum of two fractions. And then we can see if we can simplify. 1341. I think 41 is prime as well. I don't think 13 over 41 is reducible. Oh, no, it's not reducible. So it's already simplified. 47, 41 is also reduced, already simplified. So the answer in the standard form, division of two complex numbers results still a complex number. The complex number has negative 13 over 41 as you want to put a negative sign in front of it. And the plus real part, that's real part, negative 13 over 41, imaginary part, 47 over 41, and then times I. I think this result will definitely correct. Any questions about division of two complex numbers?
Yeah, I have a question, Professor.
Yes, please.
As the first one, minus 13 plus 47i over 41.
Over 41, yeah.
So I don't have to separate it like this. Will I still get it correctly? Will I still get point?
What is correctly?
Like, if I don't write it like the one you did right now for the answer, right? Minus 13 plus 47i over 41. That is, I don't have to separate it like what you did right now.
So you are talking, you're asking if
Yes.
this is good enough?
Yes.
I'm not sure. I would, when you practice in Lumen, what's the system react if you enter the result in this form?
I can't remember that. If
You don't remember that. I would recommend you go to look at this is the section 2.1. This should be section 2.1. And later when we have extra time after finish all the review, I'll look at the Lumen. Is that okay? And do not worry about that. If after the exam you feel like there is a question or a couple of questions, you have the correct answer, but the system marked incorrect because of the form, you can email me and I can look at your test. I can overwrite for you, but I cannot do that for every single person. You know, it's a lot of work. But if you remember, oh, I think that question is right, but maybe, you know, I did not split, it marked incorrect. Let me just email Professor Betty, right? I'll look it up. And then if the answer, if you really have the yellow part correct, I can override. If the system marked it incorrect, I can override that and give the point back to you. Okay. Sounds good? Yeah, again, later when we finish all the 15 questions, If we have extra time, I'm gonna look at the lumen to see what's the requirement or the expectation. To me, if this is a free response question, you guys answer everything on the paper, I would mark this correct already, right? But ideally, you want to write the result in the standard form of a complex number. A complex number divided by a constant complex number, result is a complex number. Real part plus imaginary part multiplied by the imaginary unit, right? Okay. Should we continue? This is question number 6. Let's continue question number 7. Solve the quadratic equation. Separate the solutions with a comma. Okay, the variable in this equation is r. Normally we like x, right? Yeah, but be careful, it's r. But you do not need to worry about it because you only need to enter the solutions. It gives you r already. Okay, so let's use r. Solve the equation. Solve the quadratic equation. We have 3r squared plus r minus 9 equals 0. Solve the equation, separate the solutions with a comma. Okay, it doesn't specify which method you apply, right? So you can do a lot of different methods. When I look at this problem, 3 times 9 is 27. Factoring might not be convenient, so I'm gonna apply the quadratic formula, all right? You need to memorize the formula. I'll start with identify ABC. I'm gonna write the formula, the standard form of a quadratic equation here. C is C equals 0. So firstly, we identify ABC. A is the leading coefficient, which is 3. B is the coefficient of R, which is 1. There's no number in front of R. That means the coefficient is 1. C is a -9. Be very careful with the sign. Is -9, all right? So once we have ABC, do not rush to plugging in the formula yet. The formula is x equals -b plus minus big square root b squared minus 4ac all over 2a. Remember we have a sum, right? If that ever helps you to memorize the formula, it's very complicated. The way I do it is once I have ABC, I evaluate the discriminant first, delta. Delta is this part under the radical. Yeah, figure that out. Delta is b squared minus 4ac. When the formula is quite complicated, break it down. Find the delta first. B squared minus 4ac. 4ac. B is 1, put it here. A is 3, put it here. C is -9, put it here. 1 squared, 1. -4 times 3 times -9. Negative times negative positive, right? Positive 4 times 3 is 12. 12 times 9, 108. Yeah, 108. Positive. 4 are. Okay, yeah, it is 108. And then 1 plus 108 is 109. 109. So we made the correct decision not to try factoring. Seems like this equation, the left side is not factorable in the rational number set because delta here is not a perfect square. Means our solution is going to have a radical, is going to have a square root, all right? Yeah, 109 is not a perfect square. So our result is going to be 2 irrational numbers, Okay, now we have a delta found. Let's plug in the values in the famous quadratic formula. X equals -b plus minus root delta. We got the delta already, right? All over 2a. Denominator 2a is twice of a. A is 3. Twice of a is 6. That's denominator. Numerator has 2 parts. You guys remember I said The structure of the quadratic formula is Mickey Mouse, right? Left ear, right ear, and head, right? Okay, so the denominator, the head is 6. The left ear is the opposite of B. B is 1. So the opposite of B is -1. For some reason, this part is where the common mistake occur. For some reason, students mess up this part. Maybe because of -B, it's challenging. See the -B as the opposite of a B. If B is 1, then the opposite is -1. Suppose B is a -10, then the opposite is +10. If the opposite is better, I think is better than negative, like you have to handle multiple negative signs. So -1 plus minus big square root, the radicand we already have it found is 109, right? 109 is not divided by 2, is not divided by 3, is not divided by 4, is not divided by 5, not 6, not 7, not 8, not 9, not 10. 11, no. 13. I think this is the 13, 14, 15, no, 16, 17, no, 19. I think 109 is prime. I think this is the square root of 109 is just a square root of 109. It's already simplified. Look at the left ear, right ear, and head. They have no common factor, so this is already simplified. So we can write the first solution, 91 plus root 109 all over 6. And second solution, 91 minus root 109 all over 6. And those are two solutions. They are irrational. They are irrationals. Any questions, everybody? Applying the famous quadratic formula to solve a quadratic equation is a universal method. In other words, the quadratic formula applies for any kind of quadratic equation. You can always use the formula to find the solutions. Technically, if you grasp this one method, you can solve any type of quadratic equation. Any response? Is that clear, everybody?
Yes, it's clear.
Yeah, that makes sense.
Thank you. Yeah, sometimes it does take a little bit of foundation knowledge. For example, how do you know Rule 109 is already simplified? If you watch my video, I have some tricks. How do you know if a number divides by 2? How do you know if a number divides by 3? How do you know if a number divides by 5? How do you know if a number divides by 9? I have some tricks. So I looked it up. I went over those numbers. I figured out 109 is not divisible by those numbers. Just give me 1 second, okay? Let me see if 109 a prime. A prime number only have 2 different factors. Is 1 itself. Is 109 prime? It's not. 109. Typed wrong. 109. It's 109. Yeah, okay, it is 109. It just takes longer because a very large number. So it takes longer to really confirm. It is prime. So square root of 109 is already simplified. There's nothing we can do to make it simpler. All right, next question number 8. This is about solving a quadratic equation as well. However, the question, the design of the question is to see if you know how to solve a quadratic equation by the method of factoring. Yeah, we need to solve this equation by factoring because the first part requires you to factor the left side of the equation. So you cannot avoid that. There's a way to get around, but you know, that's just a factor. Let me write the left side. 20 x squared plus 73 x plus 63. The number pretty big. Yeah, factor the left side of the equation. Okay, let's see the three coefficients. 20, 73, 63. What's the GCF of the three numbers? 20 is divided by 2, so 2 is not. 20 also divisible by 5. 5 is not, does not go into 73 or 63, so we don't have anything to factor out. Okay, so we are going to have to use the slide method. We're going to slide the 20 to multiply with the constant. We have x squared plus 73x plus 63 times 20, 1260. All right, and then this quadratic trinomial has a coefficient 1 because the 20 is slid away. And how do we factor this one? Yeah, the method is called slide, divide, slide. We do have to figure that out. We need to find the two integers. Multiply to C, which is 1260, and add up to B. B is 73. Yeah, it's not convenient, but we have to be patient. There's a procedure in my foundation class. If you go through the procedure, it doesn't matter how big the numbers is, you can always find the result. If two numbers multiply to positive, also add up to positive, the two numbers gonna be both positive. And we are going to factor 1260 now. We start from 1, 2. We have, if we get a 2, 630. If we get a 3, it's going to be 4. You can try calculator. 420. If we got a 4, it's going to be 315. If we got a 5, it's going to be, yeah, let me get my calculator. Just to make sure I don't make any mistake here.
Would the factors be 35 and 36?
Yeah, you got it already? Perfect. Yeah. So I'm trying to give you the procedure. You can also do 6. If you do 6, you have 210. You can do 8. No, you cannot do 8. You can do 9. If you do 9, you have 140. Yeah. If you do 10, you can have 126. 11 doesn't work. 12 works. 12 gives us 105. Yes. 13, no. 14, no. 15, what about 15? 15, yes. 15, we got a 1, 2. Some of you probably can get it done very fast, right? I'm going to go through the procedure. You got 15, 84, 84. They do not add up to 73, right? And almost there. 16, no. 17, let me try. 1, 2, 6, I don't think 17 works. No. 18, 1260 divided by 18. Yeah, 18. 18 times 70. Add up to 88. No. So continue. 19, no. 20. Okay, it is 20 times 63. 20 times 63. They do not add up to 73. We wanted the two numbers add up to 73. So keep going, 21, 22, 23. 24. No, 25. Let's try 25. No, 26, 27. No, 20, not 27, 20, 28. 28, 45. Oh, there we go. Yeah. 28, 45, they add up to 73. So this polynomial can be factored as x plus 28 and plus 45, right? Did you say the same thing? I believe you have the same numbers, right? Okay, so my method is called butterfly method. When I learned this part when I was little, and this method, slide divide slide method, is what I figured out that my students easier to grasp. So I have been teaching this method. So we slide and then divide the two numbers in red by the original leading coefficient, which is 20. Right after we divide, we have to simplify the two fractions. We can simplify 28 over 20 as 7 over 5 because they have common factor 4. We can simplify 45 over 20 as 9 over 4. Let me double check. 5, 20, 5, 45, 4, 20, 4, 7, 28. Okay. All right. And then, so this is the left side, right? Oh, actually, we done this one already. We first part is just this. We don't have to divide. Oh, sorry, I missed that. No, I'm sorry. One more step. Slide divide slide. So if we still have the denominator, we are going to slide the denominator back in front of x. All right. So we have 5x plus 7 times 4x plus 9. 5x plus 7 times 4x plus 9. What you can do is you can FOIL or box method to reverse the process to see if you have the original trinomial with the leading coefficient 20. So the first part, we are going to enter 5x plus 7 times 4x plus 9. Do you have the same thing, guys? 20x squared, 63, 28, 45, 28, 45 add up to 73. Yeah, that's correct for sure. So that's the first part. It's a little bit challenging because numbers are quite big. And solve each factor, give multiple values separated by comma. So now we need to know the result, right? The result, actually, we only need to look at this part. Let me rewrite that part. That part is x plus 7 over 5. And the second part is x plus 9 over 4. The solutions of the original equation, are the opposites of those two numbers I had it in yellow. So negative 7 over 5, negative 7 over 5, comma, negative 9 over 4, negative 9 over 4. So if you have a better method to factor the left side, yeah, of course, you're welcome to apply. If you don't remember much about factoring, right? Quadratic trinomial, try the slide divide slide method. It might take a little bit longer, but if you time yourself, it's not very long time. And it's very, it's very good practice to cultivate your feelings about numbers. Seriously, this is actually very, very good practice. You write a number as the multiplication of two numbers, two factors. It's very good practice. All right, any questions about number 8? If not, I'm gonna keep going. Number 9, find the length of the leg x on the right triangle below. Enter the exact value, not a decimal. Okay, cool. What is that? Pythagorean theorem. Pythagorean theorem, right? Pythagorean theorem says, if we have a right triangle, the two legs are AB, the hypotenuse is C, then A squared plus B squared is equals C squared, right? So we're gonna apply that formula. The two legs are X and 13. So one leg square plus another leg square equals the square of the hypotenuse, 17. And let's see, what is 13 square? I think it's 169. What is 17 square? Let me just double check. 17. Yeah, 289. Okay. And we are going to minus 169 from both sides to isolate x squared. On the right side, 289 minus 169 gives us 120. Right? 120. And then we apply the square root property. Square root property says if x squared equals a, then x equals plus minus root a. The base of the square equal to plus minus of the square root of the number on the right side. So we have x equals plus minus root 120. Plus minus, okay, we need to simplify root 120. It probably is simplifiable. 120, we can do 2, right? Then we have a 60 here. Continue root 2. Root 60 can be do another 2, right? And root 30. Root 30. And then we can bring this down. And root 30 is root 2, root 15. Root 2, root 15. 15 is root 3, root 5 cannot be simplified. And those root 2 can be multiplied together to get a 2, right? And I think it's going to be 2 root 30. 2 root 30. 30 does not have any positive square factor anymore. So 2 root 30 is the simplified form of root 120. 2 root 30. So the solution, 2 solutions, right? Oh, 1 solution, my bad, sorry. X is the length, so it cannot be negative. So here we have 2 solutions, x equals positive root 30 or x equals negative 2 root 30. Be very careful. Since x is the length of a side of a triangle, it cannot be negative. It has to be a positive value. So 2 root 30. All right? Yeah, this one is not that bad. This is an application of quadratic equation. And then when we solve the quadratic equation, the method we apply is the square root property. Remember, we covered 4 methods. 4 methods. Solving by factoring, that's method 1. Solving by square root property, this is method 2. Solving by completing square, I do not recommend. We use that technique to derive the famous quadratic formula, right? Method 3 is to use quadratic formula. Quadratic formula is is universal, apply to any quadratic equation. Okay, that's this problem. Let's keep going. Question number 10. Solve the quadratic equation. Separate solutions with a comma. Okay, solve equation again. I can factor this one very quickly, 33. 33 is 11, 3. 11 times 3. 11 minus 3 is 8. So I see this problem can be solved by using factoring method. Even doesn't specify what method, right? If you want, you can use quadratic formula. Totally fine with me. X squared plus ax minus 33 equals 0. The left side can be factored as positive 11, negative 13. Negative 3, sorry, negative 3. Double check. The two numbers must multiply to C. 11, negative 3, multiply to C. negative 33. They add up to positive 8. 11 minus 3 is positive 8. So very important. We might, on that section, I think we did not have a chance to cover that theorem. Yeah, the two solutions, they must multiply to the opposite of the, okay, I'll show you. So now we have the left side factored. Then we have x equals the opposite of the two real number, negative 11, or x equals positive 3. So those are two solutions. They must multiply to C. They must multiply to C and add up to the opposite of B. The two solutions is via the theorem. The two solutions must add up to the opposite of the middle term coefficient and multiply to C. And then the two numbers in the factorization, they multiply to C, add up to B. Yeah, whatever the method you feel comfortable. This is a simple one. This is a simple one. You can solve the equation. You can also use a quadratic formula, no problem. Number 11, solve the equation square root of x plus 140 equals x plus 8. This is a radical equation. I give you a procedure. When we cover this section, I give you a procedure that you can follow to solve any type of radical equation. This radical equation contains one radical. And now one radical is already isolated on the left side. So that's the ideal case, right? Since we have that already there, you know, the radical already isolated on the left side, the next step is to raise both sides to the power of 2. Why do we raise both sides to the power of 2? Because we need to get rid of the radical. The radical is like a prison. We want to set x free, then we can eventually isolate x, right? So we want to get rid of square root. To get rid of square root, we use the squaring. The square here gonna cancel the square root. Then we have the radicand set free x plus 140. And let me do the middle thing. Okay. So left side now is x plus 140. Right side, we have to square as well because we have to treat the left side, right side the same way. And then right side, I think I have to do this a lot of times. You can FOIL, right? For box method, or you use the formula. We have to do this formula many times. Maybe you just memorize, right? If you know the formula, you can just get it done very quickly. So this is x squared plus 16x plus 64. So the right side, after we expand, get rid of the parentheses, we have x squared plus 16x plus 64. 8 times 8 is 64. And everything, I'm going to go to the right side for now, because x squared on the right side is positive. So I'm going to move x over negative x, move 140 over negative 140. So if you don't like this method, what you can do is you just minus x from each side, and then minus 140 from each side, right? And then cancel, you have a 0 on the left side. On the right side, x squared, 16x minus x, 15x. Yeah, that's actually pretty cool as well. And 64 positive, 140 negative. So negative 76. Let me double check. Yeah, 76. Okay, now I'm gonna switch. And let me know if I mess up any details, okay? Switch the right side and the left side. We have x squared plus 15x minus 76. 76 to 38 to 19. Oh, okay, it's factorable. We can do 19, positive, negative. Okay. So we factor the left side. We got a x minus 4 times x plus 19. Negative 4, 19 multiplied to negative 76. 4 times 19. 4 times 19 is 76. And add up to 15. 19 minus 4 is 15. Okay, so almost there. So the two numbers in red, their opposites are going to be the proposed solution. So we have x equals 4 positive or x equals negative 19. But we are not done yet. Very important step when you solve a radical equation is to check your proposed solution to get rid of any extraneous solution. Then how do we check? We have to really plug in back the original equation to check. All right, so let's do that. I'm going to change the color. Let's plug the first solution, x equals 4, into the equation, which is the square root of x plus 140 equals x plus 8. X is 4, so 4 plus 140. X is 4, so 4 plus 8. 4 plus 140 is 144. Under the square root, 4 plus 8 is 12. Root 144 is 12. The principal square root of 144 is 12. Left side 12, right side 12. So okay, this is a actual solution. So we're gonna keep that. And now let's plug in x equals the other solution 19 into the equation. The equation is square root x plus 140 equals x plus 8. X equals negative 19. No, negative 19 plus 140 equals negative 19. Okay, I think I don't have to continue. I know we can tell now very clearly. Negative 19 plus 8 is going to be a negative number. It doesn't work. So this one is extraneous. Because the left side is a positive quantity, positive number. The left side is a square root of a positive number. 140 is bigger than 19. So the left side has to be positive, and the right side now is negative, and that is a contradiction. So negative 19 is extraneous. We're going to exclude that solution. The answer is just the one value, 4. All right? Is that clear, everybody? Solving radical equations. That's question number 11. Let's move to question number 12. This is a rational equation. When we cover this section, I think is section 2.3. I also give you a procedure, right? 5 steps. The first step, factor all the denominators. Yeah, a little bit weird, not x is s, but you know, it is what it is. So the denominator s squared minus 49 is very easy to factor. S plus 7, s minus 7. Just to make sure your s doesn't look like a 5. Don't confuse yourself. S plus 7, s minus 7. So s squared minus 49. So that's the left side of the equation. Right side we have 2. Oh, that's minus, sorry, not equal. Minus 3 over s plus 7. On the right side, this is the right side, 1 over s minus 7. Okay, so the first step of solving a rational equation is to factor all the denominators and identify excluded values for the variable. In this case, the excluded value is 7 and negative 7. The variable cannot assume 7 or negative 7 because if the variable is 7, this denominator is 0, undefined. If s is negative 7, this denominator is 0. equation is undefined. So 2 exclude the values. After that, second step is to find LCM. Remember, LCM of the 3 denominators is going to be s plus 7 times s minus 7, because it is the multiple of this one, also multiple of this one. So basically, this denominator times this denominator gives this denominator. And this denominator, of course, is the least common multiple of the 3. With that least common multiple found, we are going to multiply all the 3 parts in the equation by the least common multiple. I'm going to really leave enough space this time. 9s over s plus 7, s minus 7 times s plus 7, s minus 7 over 1 minus 3 over s plus 7 times s plus 7, s minus 7 over 1 equals right side 1 over s minus 7 multiplied by s plus 7, s minus 7 over 1. I'm going to use a gray color to cancel common factors from numerator and denominator. Cancel, 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 cancel. This step, after we multiply all the parts in the rational equation by the LCM, all the denominators are going to be disappear. We have no denominator. Now let's clean it up, all right? The gray part will not be there anymore. The gray part is going to become 1, all right, not 0. So the first part, we have 9s. Second part on the left side, we have 3, negative minus 3 times s minus 7. On the right side, we're going to have s plus 7. Very simple, right? Double check. 9s minus 3 times s minus 7 equals s plus 7. I show you every single step. When you practice, you should do the same thing. You can skip steps when you feel comfortable, and you will not cause, the skipping will not cause any mistake. That is fine. And now let's simplify the left side. Distribute 93 times s, 93s, 93 times 97, positive 21 equals s plus 7. We have 9s minus 3s, 6s plus 21 equals s plus 7 is a simple linear equation. And we are going to minus s, minus 21, minus 21. We want to isolate the s, right? So 6s minus s is 5s, and this cancel. 5s on the left side. This cancel. Negative 14 on the right side. 5s equals negative 14. And divide by 5, we have s equals negative 14 over 5. Let me double check. 9s minus 3, s minus 7 equals s plus 7. 9s, 93s, positive 21. This is 6 of them, so 5 of them, 5s, this is 21, this is 7, so negative 14. Okay, it's correct. This is the proposed solution. And the last step is to compare the proposed solution with the excluded values. When we do not see any contradiction, this proposed solution is not 7 over 97, so we keep it. The solution is going to be negative 14 over 5, right? This is question number 12. Let's keep going. Okay, number 13. Invest her savings in 2 bank accounts, one paying 5%, the other paying 12% simple interest per year. She puts twice as much in the lower yielding account because it is less risky. Her annual interest is $7,040. How much did she invest at each? Okay. Invest here X, invest here Y, right? X dollars here, Y dollars here. And this is 5%. And this is 12%. How much? 5%, 12%, X, Y. Okay. So she puts twice as much in the lower yielding. Lower yielding means the 5%. So X equals twice of Y. Low interest means low risk. So she put more money in the 5% account. Okay, so that is first the formula. That's the first formula. The second formula, we can use the interest income, right? First box, use the rate multiplied by the money in the box. 5% times X. This is how much interest from the box for 1 year. Same thing, multiply 12% the rate by the money in the box. 12% times Y. And that's the interest in dollar for 1 year from that second box. In total, 7040. Okay, so we're going to solve this equation. Equation 1, equation 2, right? Equation 1, X equals 2Y. Equation 2, we can convert those percent as decimal. 0.05X plus 0.12Y equals $7,040. Equation 2, we can use the substitution method. Plug 1 into 2. Because in equation 1, variable X is already in terms of Y, right? So we are going to copy equation 2, but copy everything except X, because we are trying to eliminate X. When we see 0.05, copy it down. When we see X, do not copy it down. Instead, use 2Y to substitute for X. Okay, we want to get rid of X. So do not copy X. When you see X, do not copy it. Use 2Y to replace X. They are the same anyway. Plus 0.12Y equals 7040. 0.05 times 2, that is 0.1. 0.1Y plus 0.12Y equals 7040. 0.1Y, 0.12Y, 0.22Y, combine like terms, 0.1, 0.12, 0.22. And isolate Y by dividing each side of the equation by the coefficient of Y, which is 0.22. Let's use a calculator. Calculator. 7040 divided by 0.22. 32 gram. 32 gram. Sometimes when you have your answer, a very convenient number, kind of like indicate this probably is the right answer. It is, okay? So Y, 32 gram. Remember, the person put more money in the low yielding account, right? So double 32, 64 gram. All right. So that's the value. We can quickly check 5% of 64 gram. 5%, 1.05 times 64, 123. So the interest from the first account, 3,200. And the interest from the second account, since we have 32 grand there, 12%, 5%, let me double check, 5%, 0.05 times 64 grand. 3,200. And 12%, 112 times 32 grand, 32, 1, 2, 3, 38, 3840, 3840 added together 7040, 7,000 interest. What's the interest? 7040. Yeah, that match. I double checked. When you check for an application problem, you do not plug your proposed solution into the equation. The equation did not exist in the problem. You're gonna plug them back into the sentences, the conditions in the words. Okay, so that is number 13. I feel like I need to hurry up. Number 14. I thought we have enough time. Okay, number 14 is a absolute equation. Absolute equation. And it only has one absolute value equation. I'm sorry. Absolute value equation only has one absolute value. So the first thing we need to do is to isolate this absolute value. We need to peel the onion, right? 6 plus 3, negative 9x plus 2. Okay, I need to do this. Okay. And minus 6 cancel. We have 3 times absolute value negative 9x plus 2. Finish absolute value equals 9. Divide by 3. Yeah, we are peeling one layer at a time. 3 over 3 is 1. So we have a negative 9x plus 2, whose absolute value equals 3. All right. So how do we translate this equation? At the same time, get rid of the absolute value. We are going to have negative 9x plus 2. The stuff inside the absolute value equals 3, or negative 9x plus 2 equals 93. Let's solve those two simple linear equations. We minus 2, we have negative 9x equals 1 over negative 9 over negative 9, x equals negative 1 over 9. And here minus 2, we have negative 9x equals negative 5 over negative 9 over negative 9. We have x equals positive 5 over 9. So the two solutions we have is negative 1 over 9, comma 5 over 9. All right. Since the method we use does not involve squaring. The method we use, when I taught this section, the method we use is to use the formula, right? Get rid of the absolute value. We don't really have to check the result. But it's always good to check if you have the time. I can quickly do that. So 1 plus 2 is 3, 9. Yeah, the first solution correct. Second, negative 5 plus 2, negative 3. Absolute value negative 3 is also positive 3. 3 times 3 is 9. 9 plus 6 is 15. Both of them satisfy the equation. So that's correct. Number 15, system. Is it possible you can use the graphing calculator embedded in Lumen to get it done? But here I'm gonna have to solve it. Equation 1, equation 2. Okay, I'm going to use equation 1 to minus equation 2. To do that, I'm gonna copy equation 1 and multiply equation 2 by negative 1. Multiply equation 2 by negative 1. So negative y, negative x squared. Well, actually, I want a positive x squared. I changed my mind. I want to multiply the first equation by negative 1. So negative y equals negative x, negative y, negative x plus 2. So that's equation 1 prime. Equation 2, y equals x squared minus 2. Equation 2. Now we're going to add the two equations together. Let's see what we have. 0, right? Negative y cancel each other. And positive 2, negative 2 also cancel each other. So left side is 0, right side is going to have x squared minus x, right? Switch the sides, x squared minus x equals 0. Keep right hand side equals 0, left side factor x out. We have x minus 1. We can write the left side as x minus 0 and x minus 1. And we can identify the solution now. X equals the opposite of 0, or x equals the opposite of the red number, negative 1, positive 1. So 0, okay, not done yet. So when x equals 0, y equals, equation 1 gives y equals x minus 2. So 0 minus 2, -2. So we got a pair of solution, 0, -2, as y equals, as x equals 1, as x equals 1. Y equals x minus 2, x is 1, 1 minus 2 is -1, so 1 comma -1. 0 comma -2 is here. 0 comma -2. And 1 comma -1 is here. Right? And those are the two solutions. Yeah, again, you might be able to just use the graphing calculator and you point it to this point intersection, they give you the coordinates. And point it here, the graphing calculator give you the coordinates. You have two solutions, two pair of solutions, just enter them and separate using comma. Next, number 16. Solve the nonlinear system. Not sure if the calculator can help you. Really depends on the convenience of the coordinates of the solutions. When the coordinates are integers, like what we had earlier, really you can just use a calculator. I don't mind you take advantage of that in the exam. But if the solution is radical, an irrational number, probably fraction, and the calculator show you the decimal, rounded decimal, so you really have to know how to solve it. In this problem, we are going to use the substitution method. Let's say this is the equation 1. And then equation 2, I'm going to minus 2y, and write x as 17 minus 2y. So this is going to be our equation 3. X equals 17 minus 2y. And then I'm going to plug 3 into 1. We are going to substitute 17 minus 2y for x in equation 1. In equation 1, we have x minus 9 to the power of 2 plus y minus 9 to the power of 2 equals 65. So we are going to copy everything except x, because look at equation 3. When we substitute, we plan to substitute 17 minus 2y for x. That means we plan to get rid of x. We plan to eliminate x. So when you see x, do not write x. You're going to write 17 minus 2y. And copy everything else. You still have -9 here, square here. Copy everything. Just not x. When you see x, you just need to replace x with 17 minus 2y. Yeah, the pink part is the only part that has changed. Let's simplify the first parentheses. 17 minus 9 is 8. 8 minus 2y to the power 2 and plus y minus 9 to the power 2 equals 65. We would have to, expand in order to solve for y. And here, I'm going to use this formula. A minus b to the power 2 equals a squared minus 2ab plus b squared. If you don't know the formula, you FOIL. For example, 8 minus 2y to the power 2 is just 8 minus 2y times itself, a minus 2y. You can FOIL your box method, right? I'm using the formula because it's faster. So I'm going to have 64 minus 32. 2 times 8 is 16. Twice of 16 is 32. Y plus 4y squared. Same here. Y squared minus 18y plus 81 equals 65. Yeah, make sure you double check your answer. Do not make any mistake. 4y squared, 64, negative 32y, y squared minus 18y plus 81. Okay, so simplify by combining like terms. 4y squared, y squared, that gives us 5y squared. Negative 32y, negative 18y, you lose both games, right? So it's gonna be negative 50y, those two terms I have to combine. 64, 81, 6481. That gives us 145, 1, 4, 5, 8, 6, 14. 145 equals 65. And we are going to minus 65 from both sides. And we're going to have 5y squared minus 50y plus 145 minus 65, that is 80. 80. Yeah, and equals 0, right? Okay, so now the equation looks good, but not simplified yet because all the coefficients is divisible by 5. So when divide by 5, divide by 5, divide by 5, and divide by 5. Then we have this. Then we have y squared minus 10y, y squared minus 10y plus 16 equals 0. And that can be factored, the left side can be factored as y minus 2, y minus 8. Negative 2, negative 8, multiply to 16, add up to negative 10. So we're going to have y equals, so those two numbers taking the opposite. We have y equals positive 2 or y equals positive 8. Not done yet. Our solution is supposed to be pairs. Okay, so as y equals 2, x equals 17 minus 2y. X equals 17 minus 2y. How do we know that? Look at this equation 3. We got the equation 3 from equation 2. Yeah. So x equals 17 minus twice of 2. Twice of y, twice of 2, which is 17 minus 4, that is 13. So one solution, 13, 2. The other solution as y equals 8. X equals 17 minus twice of 8. Twice of 8 is 16, so it's 1. So as y equals, did I make some mistake? Yeah, no. When x is 1, y is 8. Yeah, be careful the order. X value is the first component, y value is the second component. So y 1, 8. And this one is 13, 2. You know, I think you might get lucky and the calculator could actually help you this problem. Because the coordinates is convenient. However, there's no guarantee that your question in the exam also have convenient solutions, convenient coordinates for the solutions. Because you know the system switch the numbers. If they switch numbers, it might become inconvenient. All right, so that's it. Yeah, if you will have a graphing calculator, you can try that. This is a circle and a straight line. Two solutions is reasonable. If I have time, I would plug in back to double check, but we are running out of time. So number 16, number 17, solve absolute value inequality. We have 4x minus 9 absolute value less than 3. This is one of the basic absolute value inequality. Look at the note. Look at the formula that I gave you. We can directly rewrite this inequality as 4x minus 9, which is the stuff in the middle of the absolute value symbol, less than 3 and bigger than negative 3. So now we have a compound inequality. We are going to solve the compound inequality. Okay, we have 3 parts in the compound inequality, left side, right side, and the middle. We are going to isolate x in the middle. We are going to add 9 to all the 3 parts. 9 minus 3 is 6. 4x, negative 9, positive 9 cancel. So we have 4x in the middle. 3 plus 9 is 12. And then divide by 4, divide by 4, divide by 4. Cancel, we have x in the middle, isolated. On the right side, we have 3. On the right side, on the left side, we have 3 halves. So give your answer using interval notation. If we graph the solution set, this is a 0, this is 1.5, like a 3 over 2, 1.5, and this is a 3. Then the solutions is going to be this open interval, all right? Both endpoints are excluded. So the interval notation would be 3 halves, comma, 3, open, open. open this one. This one is pretty doable. This one is doable. That's 17, 18. What is this about? Okay, it's a simple linear inequality, easy. So let's see how we do that. Negative a minus 14x is bigger than or equal to negative 4 plus 3x. You know, I like to separate the middle, separate the two parts. I'm going to isolate x on the left side. To reach that goal, I'm going to get rid of 3x from right side by minus 3x from each side. And I want the numbers to the right side. So I want to get rid of negative a from left side. To do that, I plus a to both sides. You know, this actually is pretty cool. I normally use the side and sign method, but this is not bad at all. Cancel. We have negative 17x bigger than or equal to. Apologize, my daughter is being excited. I don't know why. So they cancel, and here is a 4. Negative 13x bigger than or equal to 4. And very, very important, when we divide each side of an inequality by the same negative number, we must remember to do something special. The thing special is you flip the direction. Yes, flip the direction of the inequality symbol. So we divided by negative 17 to get rid of the coefficient. Then we can isolate the x on the left side. But this time x is less than or equal to negative 4 over 17. All right. So the result need to be given. Write your solution in interval notation. Type this one has solution for sure. So this is real number line. This is 0. This is negative 4 over 17. All the real numbers less than or equal to negative 4 over 17. They are solutions. So that's one interval with left endpoint negative infinity, right endpoint negative 4 over 17, left open, right close. Right close is because negative 4 over 17 is also a solution because x is less than or equal to. When you have a bar here, that means you're gonna have the endpoint included. So it's bracket, left open, right closed interval. So that is 18. 2 more questions. If you don't mind, I'm gonna keep going until we finish, right? Number 19, solve for x. This is a compound inequality, pretty simple. Negative 14 is less than negative 6x minus 3 is less than negative 9. Okay, left side, middle, right side. Our goal here is to isolate the x in the middle. To do that, plus 3, plus 3, plus 3 to all the three parts, negative 14 plus 3, negative 11. In the middle, negative 3, 3 cancel, so we have negative 6x. And on the right side, negative 9 plus 3 is negative 6. Okay, here is tricky. In order to isolate x in the middle, we need to divide by negative 6, all the three parts by negative 6, divided by negative 6. Remember, when we do that, we have to switch the order, switch the direction, all right? Gonna flip the, even in the compound inequality, same thing. We need to flip the inequality symbol direction. So in the middle right now, we have x isolated. This is bigger than 1, less than 11 over 6. 11 over 6 is bigger than 1. So, but since in the real number line, you know, numbers from left to the right, numbers getting bigger, right? So we get used to start from smaller number and then go to, when we go to the right, we have a bigger number, right? So it won't get a confusion because 1 is smaller compared with 11 over 6. So the solutions are real numbers between those two numbers. Of course, we know 1 is smaller, right? And 11 over 6 is bigger, and open because the inequality symbols do not have the bar under. Means the two endpoints are not part of the solutions. So we have to use open. It's an open interval for this compound inequality. The solution says an open interval. Last question. Can we get it done in 2 minutes? Solving the system. Okay. All right. This one is easy. one step we can isolate. Eliminate. One step we can eliminate the y, because in equation 1, coefficient of y -4, in equation 2, coefficient of y is +4. If we add them together, -3x, 1x, -2x, 4y, +4y cancel. On the right side, 9, -3, 6. So we have -2x for more space. -2x equals 6 divided by -2 divided by -2, cancel, x equals -3. Well, x equals -3, plug into which one is simpler? Equation 2 is simpler. Is x plus 4y equals -3. Then we're going to plug in x value, the value of x, -13, plus 4y equals -3. Plus 13, 4y equals 10. Over 4, y equals 5/2, 5/2. So when x equals -3, y equals 5/2. And that's the solution. This is a...
Where'd you get +13?
What?
Where'd you get +13?
Oh, my bad. Yeah, where did I get a 13? Oh, why did I get a 13?
Yeah.
Plugging in x equals 3. Oh, plugging in x equals -3. My bad. You're right. I apologize. Okay.
I got y equals 0.
Yeah. I apologize. It was too fast. X equals -3. Yeah. So we're gonna plug in x equals -3. -3 plus 4y equals -3. And if we add a 3 to both sides, we cancel those constants. We have 4y equals 0. Divided by 4, divided by 4. We have y equals 0/4. Do not get confused. The 0/4 is 0. 4/0 is undefined, but 0/4 is 0. So we have x equals -3, y equals 0. We can quickly double check. +9, yes. And here, -3, yeah, that's correct. Appreciate that you reminded me. I will hate myself if I make some mistakes. I apologize, the time wasn't managed the best. We actually kind of rushed through the last few questions. But I covered everything we need to cover. Just to watch the video. You can maybe in YouTube, you can adjust the time maybe to 1.5 for the last few questions. So those are everything. And by the way, I extended the midterm because we have a spring break, right? Like 10 days, we don't, like 1 week in the middle. So I think I extended the midterm to 25th. So you still have Monday and Tuesday. After you come back from the spring break, you can take the midterm. Thank you guys for coming. Feel free to email me if you have any questions. I'll see you on Tuesday.
Miss
Thank
Guo,
you. See you on Tuesday.
Yes,
could
please.
you reopen the homework in section 2 so I could use it to study for the test?
Can you email me? I'll do that later today.
Okay, yep.
It specify which sections you need me to reopen them.
Okay, thank you.
You're welcome. Bye-bye.
Bye.
Have a good weekend.
Thank you too.